Good morning. This is Ms. Billerbeck, and we're going to talk about solving simultaneous linear equations in two variables using substitution. So we use substitution all the time in our lives. We substitute when we go order something at like a burger. You know, I want some sauteed mushrooms with those onions and no cheese, please. So there we go. That's a form of substitution. So now we're just going to substitute one thing from here into there. So first let's get this y isolated. So it's a negative y, so I'm going to use its additive inverse and move it to the other side. So I have 3x equals y plus 1. And then I want this one to go over here. So I'm going to use its additive inverse. And I have 3x minus 1 equals y. Now I have y isolated. So I can take this whole expression for y and substitute it right there into that y. So now let's put this equation in with a substitution. So we have x plus 2, but we're not using y anymore. We're going to use 3x. 3x minus 1 equals 12. So we're going to grab this number with its sign in front of it and distribute. So we have x plus, and then 2 times 3 is 6x. 2 times negative 1 is minus 2 equals 12. So I want to move that to the other side. It's a negative 2, so its additive inverse is a positive 2. And what I get is 14 here. That's a 0. Negative 2 plus 2 is 0. And this is a 1x plus 6, so that gives me a 7x. So now I have one thing here, one thing here. I can use a multiplicative inverse instead of an additive inverse. So this is 7 times x. The opposite of multiplication is division. So we divide, and we get x equals 2. And now that we have x equals 2, we can substitute it back into here. So we have 3 times 2 minus 1 equals y. So that's 6 minus 1 equals 5. So our answer to the problem, and it's always in x comma y notation, is 2, 5. So first I write the x, which is 2, then the y always goes second. So this gives me my solution, which is the intersection of these two lines. Okay, so they intersect in one point, and that is their solution. All right, so let's try another problem. Well, this one is nicely isolated already. We have y equals that. So we're just going to take this y and put it right there into that equation. So we have 3x plus 5 times negative 4x plus 10 equals negative 18. So I'm going to grab this 5 with its sign in front and distribute. So I have 3x, and then 5 times negative 4 is negative 20x. 5 times 10 is 50, and then that equals negative 18. So I'm going to move this 50 to this side using an additive inverse of negative 50. That's going to give me a negative 68 right here. And then 3x minus 20x gives me a negative 17x. So now I have one thing here, one thing here. I can finally use that multiplicative inverse. Okay, so he uses an additive inverse up here. Multiplicative inverse gets to be used only when we have one thing here, one thing here. So I have negative 17 multiplying x. The opposite then is division. So we're going to divide by negative 17. And what this gives me is x equals positive 4, because I have a negative 68 divided by negative 17, which is a positive 4. So now I can take this x equals 4 and put it in here. So I have negative 4 times 4 plus 10, which gives me negative 16 plus 10. And that's going to give me negative 6 for my y. So I have y equals negative 6. So again, I always put the x value first, which is 4, and the negative 6 here. This is the intersection of these two lines, which is the solution. The point of intersection of the two lines is the solution. All right, let's try this one. Well, this one's not quite set up right, so I need to add 1 to both sides, because I need that y isolated. I could isolate x as well, but this is just too easy to isolate y for this one. So that's my equation for y equals. Now I'm going to put it right in here. So I have 3x minus 2 times 2x plus 1, is that y is now going to be this expression, equals 1. I'm going to grab the negative sign with the 2 and distribute. So I have 3x, and negative 2 times 2x is minus 4x. Negative 2 times 1 is negative 2, equals 1. So now I'm going to add a 2 to both sides. And that's going to give me negative x, or 3x minus 4x is a negative x. This is just 0, negative 2 plus 2. So I end up with negative x equals 3. Well, I can't have negative x, so I really have a negative 1 multiplying there. So I'm going to divide by negative 1 on both sides. I could also multiply by negative 1. So that's my multiplicative inverse, is dividing by negative 1. And then this gives me x equals negative 3. Now that I have that, I plug it back in here. So I have equals 2 times negative 3 plus 1 equals negative 6 plus 1. So y equals negative 5. So my point of intersection is negative 3, negative 5. Now, a check for this, which I haven't talked about, but a check is you just plug it back in. So 3 times negative 3 is negative 9. And then negative 2 times negative 5 is a positive 10. So negative 9 plus 10 is 1. So that checks out. And this one is 2 times negative 3 would be negative 6. And negative 5 minus 1 is also negative 6. So that checks out as well. Okay, so that's how you quickly check your point of intersection, which is the solution. And remember, we always write coordinates x, comma, y. Sometimes we don't have intersecting lines, so we get strange things that aren't coordinate solutions. So let's take a look at what that might look like. So this first one, we're going to substitute this y in here. So we have 2x minus 2, and we're going to put x minus 2 in there, equals 4. So now I'm going to grab this and distribute. So I have 2x minus 2x, And then negative 2 times negative 2 is a plus 4 equals 4. Well, 2x minus 2x is 0. So we end up with 4 equals 4. Wait a second. I have no variable. How am I going to find x? Well, x can be anything in this case, because this is always true. Okay, what we just have found is that this line and this line are the same line. These are called coincident lines. They're not intersecting lines. They're coincident lines. They're a special case where it's the same line. It's just this equation's hiding the fact that it's the same as that equation. Okay, so it's always true. So the solution is all real numbers on the line. Okay, as I said before, it is not infinite solutions. Okay, it's all real number or infinite solutions on the line. So we could say infinite solutions on the line. Okay, because there are points that are not on that line. And they are not solutions. So we can't just say infinite solutions, because it's infinite solutions on the line. So most people forget the on the line, but that is very, 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 very important. Okay, all real numbers on the line, infinite solutions on the line. Okay. Okay, another case, something like this. So if I move this around, I have y equals negative 2x plus 4. Now I'm going to substitute that in here. So I have 2x plus negative 2x, and then that's just plus 4. I don't really need, well, I'll leave it like that, equals 3. Well, 2x plus a negative 2x is 0, so then I have 4 equals 3. Wait a second, 4 does not equal 3. This is never true. Okay, so this is no solution. So when we're doing our algebra, this is what a parallel lines look like mathematically. Okay, so there's no solution. We're going to see 4 equals 3. Okay, where it's never true. Okay, mathematically, this is what parallel lines look like. All right, so that's my lesson for today on solving systems of linear equations using substitution. Have a wonderful day.